So this is over 8-3, which is over geometric sequences and series. And the first one, we talked about the arithmetic, where it's what you add or subtract. But when you come to the geometric, it's when you multiply or divide. Thinking about it as multiplication is usually better. The formula that you need to know for this one is a sub n is going to be equal to the first term, a sub 1, times r, which is your common ratio, which is raised to the power of n minus 1. Okay? And that r is your common ratio. And that common ratio is, again, what you multiply or divide by to get to the next number of your sequence. All right, so knowing that you are multiplying or dividing is really, really important. Obviously, if you're not adding, subtracting, multiplying, or dividing, then it's going to be nothing. Your series is going to be nothing. The formula that you sort of need to know for this, or how we were to obtain our common ratio, is by taking your second term, your a n plus 1, and dividing it by your first term, or however many terms you want to look at when you get to your sequence. Again, sometimes it's really obvious when it comes to arithmetic and arithmetic sequences, just because it's only adding or subtracting. It's not a huge deal. But when it comes to geometric, it's always best to sort of follow this rule. And I know in the other video I said you didn't really have to follow it. If it was confusing, you could ignore it. But when it comes to this one, you definitely want to follow this rule, taking the second term and putting it over the first term and going from there. So let's go to example 1.2 and look at those and figure out, well, what is R? Is it arithmetic or is it geometric? All right, so example 1.2, before we even get started, let's just try to find the common ratio for all of these. Again, just so that we can get used to this process and making sure that we have this right. So underneath this sequence, I'm going to go ahead and just take the second term and put it over the first. 12 over 6 gives me a ratio of 2. Okay. Again, you have to make sure that all of this is consistent throughout. So that is the work for this one. The next one would be 20 over 12, which is actually, let's say 20 over 12, 20 divided by 12 is going to equal 1.6 repeating. So if we were to put that into a fraction, it'd be 5 over 3. And this is not consistent, okay? It's not consistent when we are multiplying or dividing. So we know it's not geometric. We can do a quick look and see if we are maybe going to have an arithmetic sequence. To get from 6 to 12, we would have to add 6. To get from 12 to 20, we would have to add 8. So now we see that it's neither geometric or arithmetic. So I'm going to say it is neither. Right? So now let's go back to, and since it's neither, we don't have to do anything. So we can go to letter B and letter C and see what the common ratio of these are. All right? Take 64, divide it by 256. And I know that 256 is bigger, but remember the process is you take the second and you put it over the first. So that's why 64 has to go on top. And when we do this, we can reduce it down to 1/4. Same thing again with our next pair. 16 divided by 64 is again going to be reduced to 1/4. Then we do 4 over 16. 4 over 16 is going to be reduced to 1/4. How shocking. Again, 4 and 1. Put that in our ratio like this, the one that I'm circling. That becomes 1/4. Okay, so we know for sure that this right here is going to be a geometric sequence. We know it's geometric because really what we're doing is we're multiplying by 1/4 every time. If you type into your calculator 256 times 1/4, it's going to give you 64. If you multiply by 1/4 again, it gives you 16. If you multiply by 4, it's going to give you 4. Another way you can think about it is you're dividing all of these by 4 because that is what 1/4 means. 4 is in the denominator. That means it's dividing. So you could think about it as 256 divided by 4 gives you 64. 64 divided by 4 gives you 16, etc. So we know that this is geometric. So now I can write my explicit formula, which is a sub n equals our first term 256 times, and I like to put our common ratio in parentheses, and also I just make it a good rule of thumb that any number that is a fraction I put in parentheses. So this is going to be a common ratio of 1/4 raised to the power of n minus 1. Then the instructions say find a sub 6. So now I'm going to take this and figure out, well, what is the sixth term going to be if I were to continue this out? You can plug in your pieces. A sub 6 is going to equal 256 times 1 divided by 4 raised to the power of 6 minus 1, which is the fifth power. So literally you can type this whole piece into your calculator, if you have one of mine at least. If not, you might have to go piece by piece, but your answer should end up being 1/4. So a sub 6 is going to equal 1/4, and this is our answer. All right, if you want to see the work behind that, I can show you that 0.25 or 1/4 raised to the fifth power is going to give you 256 times 1/1024, and then 1/1024 times 256 is 1/4, or 0.25. All right, so that's when it's really small. So let's try the next one, and let's see if it's just a little bit better to work with. C, we have our 2 and -1. If we put that on top of each other, 2 divided by -1 gives me -2. Then I go to the next one. I take the second number and put it on top. -4 over 2 is -2. Then I go with the next one. 8 divided by -4 is -2. -16 divided by 8 is -2. So I know I do have a common ratio. Therefore, it is geometric. And I can write my explicit formula, which is a sub n is equal to my first term, -1, times my ratio. Remember, the ratio has to be in parentheses, -2. All of that raised to the power of n minus 1. Then we can do the work and find, well, what is a sub 6? Plug all that in, -1 times -2, 6 minus 1. -2 raised to the fifth power is going to be -32. And -32 times -1 is positive 32. So a sub 6 is going to equal positive 32. And this is my answer. So it's the same process as we did before. It is only slightly different and only slightly harder just because we're dealing with multiplication and division. And therefore, we have a little bit more of fractions in our life. But don't worry about it too much. It's going to be very, very straightforward as long as you remember this piece right here. Do not forget it. It's very, very important. Let's go to example 2 now. So just like before in the arithmetic sequence, we are asked to write the explicit formula again, but we're not given a sub 1. We're given a random term in our sequence, and we're given our ratio. So again, we're going to do the same thing, again, go through the same process and find our answer. We got to plug in all of our pieces. A sub n in this particular case is going to equal 12, and that is going to equal a sub 1, which I don't know, my ratio, which is 2, and we are looking for the fourth term, so 4 minus 1. We do our math to get a power of 3. 2 to the third power is 8. And then to divide all this out, 12 divided by 8 is going to give us 3 over 2. So if I were to write my answer, write my explicit formula, it would be a sub n equals 3 over 2. Remember, if it's a fraction, you put it in parentheses. And no matter what, you put your ratio in parentheses. So that would be 2 to the power of n minus 1. All right, same process again, but with the next problem. And I'll let you do letter C by yourself. And I'll put it off to the side just so that we have a little bit more room. -96 is going to equal a sub 1 times -2 to the power of 6 minus 1. -96 is good to go, but we need to subtract our exponents and get a 5. we had this problem earlier with negative 2 to the 5th power. It's going to give us a negative 32. And negative 96 divided by negative 32 gives us an answer of 3. With that, we can plug in all of our pieces. A sub n equals 3, not a fraction, so no parentheses, times the ratio, which is negative 2, must use parentheses, and minus 1. And this is our answer. Take a couple seconds and do letter C. So if you set it up correctly, you should have 30 is going to be equal to a sub 1 times 1/2. Our ratio has to be in parentheses, raised to the power of 2 minus 1. Do some quick little math, and we can obviously see that it's just going to end up being 1. And since it's just 1, we don't have to worry about it. Instead of dividing out, we are actually going to multiply because it's a fraction. Or if you want to imagine it as dividing 1/2, you can. 30 divided by 1/2 is possible. But if you plug into your calculator, you should get an answer of 60. And then from here, we can go ahead and plug it into our explicit formula. A sub n is going to equal 60 times our ratio, 1/2, to the power of n minus 1. And this is our explicit formula. The last little bit is our series, and so let's go ahead and flip the page and go to that last example. So our geometric series formula is going to be S sub n is equal to a sub 1, our first term, times 1 minus r to the power of n over 1 minus r. And again, just like I said in the arithmetic sequence and series video, this formula was technically used in our 8-1 section. It was just that it was, I guess you could say, hidden, and this is specific for geometric series. So again, 8-1 was very general, while this one is specifically looking at arithmetic and geometric. And of course, I broke it up, so therefore it's just geometric. But we can go ahead and make sure that we know that this is always going to be looking for exponential functions. Okay, always, always, always. So it'll always be in the form of a times b to the x power, where b is our common ratio. So we can, with that in mind, look at our next piece. And with this one, it's pretty nice because we only have to do one thing, and that is find our a sub 1. A sub 1 is going to equal 5 times 1 minus 1. 5 times 1 minus 1 is actually to the 0 power, and anything to the 0 power is going to equal 1. So we know that a sub 1 is going to, or our first term is going to be 1, and then we plug it into our formula. So it would be s sub n is going to equal 1 times 1 minus 5, because 5 is our common ratio. We know that is our common ratio because we said earlier that the b was our common ratio. And you can always think about it as, well, what is the base of your exponent? And in this particular case, 5 is the base of our exponent. So to be, our ratio is 5, and to the power of n, remember that is based off of our upper limit, which in this case is 8, 1 minus 5, and then from here we just focus on the top. If we were to just focus on the top, we're going to get negative 3,90624, all of that over negative 4. And if we divide that out, we're going to get 97,656. And if we multiply that, anything times 1 is itself. So our final answer is 97,656. And this is our answer. So if we were to sum everything between our first and our 8th term, we would get an answer of 97656. So let's go to letter B, and I'll give you a couple seconds to get started on that one. So with this one, again, we should have figured out what is our a sub 1 going to be. Plug in that 1, and we should get 1 minus 1 again, which gives us a power of 0. Again, anything to the power of 0 is just 1, so we get 4 times 1, which is 4. Take that and plug it into our formula along with r. Remember, r is our base of whatever our exponent is, which is 3 this time. So we should get Sn, or S sub n, is going to equal to 4 times 1 minus 4 to the 10th power over, not 4 to the 10th power, it's going to be 3 to the 10th power over 1 minus 3. Use our math. We should get a negative 5902, or 48, not 24, but 48 over negative 2. We, from there, after dividing, should get a positive 29524. And then by multiplying by 4, we should get a total of 118,096. So our summation should equal this. Final one, same process. A sub 1 is going to be 5 to the power of 1/3, 1 minus 1, which is going to equal 0. Anything to the 0 power is going to equal 1. So our a sub 1 is 5. Again, our r is our base, which in this particular case is 1/3. Plug it into our formula. 5 times 1 minus 1/3 raised to the 8th power. All of that over 1 minus 1/3. This one you're definitely going to have to make sure you use a calculator and keep everything as a fraction until the very end, where you can round if you would like. I tend to keep everything as a fraction, and this is not going to be your normal type of problem. This will be very uncommon, but I do want to make sure you understand the process of what to do here. So if we just focus on that numerator portion, 1 minus 1/3 raised to the 8th power, you should get a fraction of 6,560 over 6,561. And then 1 minus 1/3 is just 2/3, so our denominator is going to say 2/3. So this is actually a complex number, not a complex number, but a complex fraction, where it's a fraction over a fraction. And so if you want to, you can separate it by doing keep, change, flip, or you can plug everything into your calculator and have it do all the work for you. If you do that correctly, you should get a final answer of, or not a final answer, but inside the parentheses, 3,280 over 2,187. Multiply that by 5, keep it a fraction, and you should get 16,400 over 2,187, which is approximately, if I remember correctly, 2.5. This is your final answer, and that is it for this. Again, you do not have to focus on your homework down here at the bottom. You can ignore that. Just make sure you're checking online to see what is your homework assignment. If you have any questions, let me know.